Okay, here's where we left off yesterday. We were going through. We got just a couple more to go, and then I think we'll go to the lab, finish this up, let you go work on this stuff a little bit, and then we got one more of these to go through, but I don't think we'll do it today. So here's the next one to look at. When a polynomial function of least degree has real coefficients, leading coefficient of 1, and these zeros. Now, what's that mean? Just means you're going to build the easiest possible translation, easiest possible polynomial from these zeros. This is what we did in 6-7, I think it was, where you turn the zeros into factors, just expand them out. Oh, excuse me, gosh, allergies. So how's that work then? Remind us, somebody, how we do that. Okay, if these are the zeros, how do we turn those into factors? Yes, ma'am.
Like x plus 4.
Okay.
X minus 4.
Okay. Good. So we're just subtracting these values from x. Good. So x minus negative 4 times x minus 4 times x minus 3. And that's our function right there. That's it. But we just want to write it in standard form. And they're asking specifically for the coefficient of x squared. So after we get it all expanded out, what's the coefficient of x squared? Okay, so which of those two, not that it makes a huge difference, but can anybody tell me perhaps a strategy for what two they would expand first? How? Good. Yeah, we have conjugates here. It's a good idea. If we're going to multiply two of them out and we have conjugates, do the conjugates. Because when we FOIL those out, look, we get x squared. First times first is x squared minus 4x plus 4x. So those cross terms go away. And then I just end up with a minus 16. Okay, and then got to FOIL that out, right? So we get first times first is x cubed. I guess you don't need parentheses, do I? X cubed minus 3x squared minus 16x plus 48. And then we want the coefficient of x squared. So what is it? Negative 3. Yeah, good. Okay. All right, so what about okay. That has at most how many real solutions? 5. Yeah, we know it's got exactly 5 complex zeros. The imaginary ones have to come in pairs, so we could either have 5 real, 0 imaginary. Would be the next possibility. Can't have 4. 3 and 2, 3 real, 2 imaginary. 1 4. Yeah, 1 real, 4 imaginary. Good. So the most we could have would be 5. Okay, and then, oops. I think this last one. Yeah, last one. Okay, using finite differences, determine the degree of the polynomial function that matches the following data. So all they want is the degree. We don't want you to come up with the function, just the degree. In the graphing calculator part, you're asked to actually fit this and come up with a polynomial. But here, just the degree. Okay, so how do we do that? Remember how we did that. This is a little bigger. Okay, what do we do with the y values for finding finite differences? Notice the x values are, they need to be in sequential order, which they are, right? They're just, going from -3 up to 4 in order. What do we do with the y's? I mean, if they're differences, that means we're subtracting, right? So it's this stuff, right? What's that one going to be? Negative, yeah, because we're just, how much is x changing from -1 to -3? Well, it's changing by -2. It's going down by 2, isn't it? The way we find those, -3 minus -1 is -2, right?
0, 2, 4, 6, 8.
And so these are just all 2's then, aren't they? So what's the degree? 2, yeah. It took us 1, 2 orders to get the differences to get the constant one. So that means it's a second degree polynomial. So if we were going to, like say on the graphic calculator portion then, if we were going to fit this polynomial, this data to a polynomial, well, what kind would we pick? Quadratic, good. And how many data points would be put in? 3, good, I'm seeing 3. You could put them all, but why waste the time? You only have to put one more than the degree of the polynomial. So we could, for example, just pick, these easy ones right here. Right? Put in that group of 3, for example. Any of them. Doesn't make any difference.
Could you also do that on the way that you showed us?
The what?
You showed us on how we could do
The trick, you mean?
Yeah.
Well, that's if you knew the function, you could tell what those differences were going to be. But that's kind of a weird question in a way, because the point of doing this typically is not to, you're not given the function to begin with, you're finding the function. So this is how you do it. Okay? Questions? All right.